If we have a multiple cargo, the calculation might be not as easy as what we have seen above. So let's assume we have, this is the lever, and we have multiple cargo. One cargo is here, one is here, one is here. We have 1, 2, 3, 4, 5, 6 cargos. Each one, they have their own weight. Okay. Now I would just have I calculated with 6, but in the real vessel there are much more. So we have 6 cargo, and we want to find the center of gravity of this object. That's not easy to process with the simple previous one. What we need to know, we need to know position of each cargo. Otherwise, we are not able to calculate center of gravity. We can assume any point in the lever as your reference point. You have to select a reference point. For the vessel, if I draw a vessel, we look at from the forward, and this is midship cross section. The bottom of the vessel, which is keel point, and we name it as a K. All the time we use keel point as a reference, which is the end of the lever, end of the vessel, because definitely you cannot load any cargo below the vessel on the sea. So you are going, it is better to select one end of your lever as a reference point, and the distance of all the cargoes to the reference point. D1, D2, from point 3, D3, and the same as the D4, D5, D6, and D4, D5, and D6. So what we have, we are going to dynamically and statically balance our lever. To be statically balanced, it means our total weight, or for our vessel, which is displacement, will be sum of all of the weights. W1 plus W2 plus W3 plus W4 plus W5 plus W6. Okay, so this is the total weight of the vessel, and let's assume the center of gravity at the end to be, we don't know currently position of center of gravity. Just we assume the center of gravity will be here. And this will be position of center of gravity, and the distance will be dt. Just I name it as a dt. So the amount of the load from the center of gravity, or load total, we found it from here, which is displacement, and we want to find the position of center of gravity from our reference point. The object must be, the vessel must be dynamically balanced. So dt times displacement must be equal to, this is the, for dynamically balancing, you have to use the moment. So the moment for our total weight must be equal to moment for all the cargoes. Should be equal to W1 times D1 plus W2 times D2 plus W3 times D3 plus W4 times D4 plus W5 times D5 plus W6 times D6. So, but while we know all the information from one side of the equation, we are able to find the next part also from the other side of the equation. Total displacement, we have find it from the previous one, and just you need to find the position of center of gravity. You are able to calculate it. But what will happen if we have so many cargos? This will be difficult. It still will be difficult to calculate it with the straight formula like as this one. To solve this problem, we are going to develop an Excel sheet, a spreadsheet. We are going to prepare a chart. We are going to prepare a chart, and this chart we have weight of each cargo, distance of each cargo from the reference point, and in the next one we are going to calculate the multiplier of them, which is moment. For moment, it will be W times D. So no matter how many loads you have, W1, W2, W3, how many cargo you have, and distance of the cargoes from your reference point. In the next column, we are going to calculate the multiplier, which is the moment. It's W1 times D2, W2 times, sorry, this is D1, W3 times D3, and goes on. So at the end, we need to summarize whatever was here and whatever was here. Sum of weights and sum of moments. Position of center of gravity. Just again review what was at above. Position of center of gravity, which was dt times total weight, was equal to sum of the moments. So we are doing the same. We are doing calculate each moment, sum of the moment, calculate sum of the weight, which will be our displacement, and position of center of gravity will be all the time sum of moment over sum of weight. So just remember, and here, if you add the cargo, if you add the load, your weight will be plus. If you remove any cargo, you have to mention it as a minus, and at the moment also you will have the minus. So if you add the cargo, you are going to mention the weight at the table as a plus, and if you remove it, you have to mention it as a minus, and definitely in the multiplier also you have to consider the minus. So, and while you are going to calculate sum of the moments, you have to take care which one was plus and which one was minus. And at the end, easily you can calculate position of center of gravity. There's no matter you are calculating transversal or longitudinal, you can use the same concept. Okay, now let's bring our exercise to a real vessel. If we look at the vessel from the forward, we are drawing midship cross section, as you see here, at the bottom of the ship, which is our keel, and we name it keel point or K. We use keel point for reference while you look at the midship cross section, and that's for transversal stability. The important point we have here, one of the important is our center of gravity, which is G, and the distance between center of gravity to the keel point is kg. Another point is center of buoyancy. If you remember from the flotation and what we have reviewed previously, if we want our vessel to be float on the sea, we have to have a similar weight, similar force of the weight applied by the water. As a result, our vessel be float. We have a downward force from our center of gravity. Downward force from center of gravity, and an upward force will apply by the water to the vessel from center of buoyancy, and these two forces must be equal to be able to keep the vessel float. So displacement is the force applied by the air to the gravity, and buoyancy is the force applied by the water to the vessel. These two are equal. Another point is M or metacenter. The metacenter is a point, the imaginary point, which if our vessel going to incline in either side, will incline around this point. This looks like as a pivot point or point for the pendulum, which our vessel will be moved around this metacenter point. We will work for calculating how to calculate the metacenter. But first we want to calculate center of gravity. If we look at the vessel from the side, and this is longitudinal cross section of the vessel, and this line is a midship cross section. This is the midship line. So this the distance to the aft is equal to distance to the forward. In center of gravity, we are going to calculate the distance of center of gravity from the midship, and we call it longitudinal center of gravity.